Hello Year 12 and welcome to our second video here for series and sequences. Today we're looking at arithmetic sequences. Now these are a sequence, an ordered list of numbers. But for an arithmetic sequence, consecutive terms have the same difference. So to get from term 1 to term 2, we add or subtract the same number that we would add or subtract to go from term 2 to term 3. Or in other words, T2 minus T1 equals T3 minus T2, or T11 minus T10. We have a common difference, which we abbreviate with a lowercase d. Okay, so this is an arithmetic progression, or an arithmetic sequence. Okay, and each term changes by the same amount. Here's an example. We're asked to list the first 4 terms of this sequence and then show that it's an AP with a common difference of 3. So the first term is 4 plus 3 lots of 1 is 7. The second term, 4 plus 3 lots of 2 is 10, 13, 16 and 19. Okay, we use that formula to calculate each term. Now I want to show that it's an AP, an arithmetic progression. To do this, we find the difference between consecutive terms. So T2 minus T1 is 10 minus 7, which is 3. We find a different pair of consecutive terms. I'm going to go T3 minus T2 is 13 minus 10, which is also 3. That shows that we have a common difference, and that common difference is 3 as required. Okay, arithmetic sequence changes by the same amount from one term to the next. Right? D is our common difference. Now, if I'm to calculate the nth term of an AP, okay, rather than just keep adding that number on every time, we have a formula that we can use to calculate this. So, A is the first term and D is the common difference. We have a formula here. The nth term is A, that's our first term, plus the number of steps that we have gone beyond our first one. So n minus 1 multiplied by the difference. Right here. So we started at A. To get to the nth term, we've gone n minus 1 steps forward because we started at 1. We've gone n minus 1 steps forward. Each of those steps is d in size. So n minus 1 times d plus a tells us the nth term of an arithmetic progression. So here's another example. 8, 13, 18, 23, 28 is an AP. We're told that that is the case, so we don't have to prove it, but we want to calculate these things here. So first of all, A is the first term, so it's 8, and D is the common difference. We can see there that each of those terms is increasing by 5, so it has a common difference of 5. Part A done. Part B is maybe even easier. T3, well, that means the third term, which is 18. T6, well, we have the fifth term, and I know the common difference. So we could use the formula to calculate T6. However, it's probably a little easier just to go one step forward from T5. So 28 plus 5 is 33. Now we're asked to find T9, and I could add 5 on a few times, but let's use the formula. So it is A plus n minus 1 times D. So it's 8 plus n minus 1, 9 minus 1, times 5, which is our common difference, which is 48. So that's our 9th term, is 48. Righto, let's have a look at another example here. How many terms are in this sequence? Remember we said that a sequence can have either an infinite or a finite number of terms. Well, this one definitely has a finite number of terms. We can see the last term is 917. The first term is 26, so that's great. We know what A is. If we are to assume in this question, I guess we kind of can because that's what the exercise is, that it's an AP. We could prove that it is to begin with, but for now, I think we can assume that's an AP. And I can see that my first term, T1, is equal to 26, and my terms have a common difference of 9. They're increasing by 9. So a equals 26, t equals 9. Now I'm going to use that formula again for the nth term. Remember, the nth term of an AP is equal to a plus n minus 1 times d. So, oops, I've hit the wrong button there. Blooper. So let's have a look here. That means that my nth term is 917. I don't know what n is at this stage, but also I know that the nth term is 26 plus n minus 1 times 9. So that means that 917 equals 26 plus n minus 1 times 9. And then I can solve this equation. Okay, so we step through these things here. We find that 9n is 900, which means that n equals 100. There we go. All good. So that's it for arithmetic progressions for the time being anyway. What do we learn about? Well, consecutive terms in an arithmetic sequence have a common difference of d. That's what makes it an AP, an arithmetic progression or an arithmetic sequence, is that consecutive terms always have the same difference. Right? If they don't, it's not an AP. We could demonstrate that by finding that difference in more than one place, and that'll demonstrate it for us. Also, we've introduced this formula here. Let's get my head out of the road there. It's probably a good idea. That the nth term is calculated using this here formula. Rightio, that's good. Next up, we're going to look at, what are we going to look at? Geometric sequences. Rightio. I'll see you in that next video. If you've got any questions about today, make sure that you ask your teacher. Okay, thanks people.